Today we're looking at the Consulab speed and position sensors trainer. On this trainer, then there are actually four sensors, but two are the same sensor, and so we're looking at the magnetic induction sensor number one, the Hall effect sensor number two, and the magnetic resistive sensors 3 and 4. It's just that they have different types of wheels. One has a radial wheel and the other one has an axial strip with the magnets embedded. After a bit of rearrangement, we can see inside of the case here, this is designed for safety. We have an electric motor here to rotate our two reluctor wheels and our other wheel that has the magnets embedded. Along with that, now we have our resistive magnetic induction sensor right here. And then we have our Hall effect sensor here. And then on the bottom, we have the two magnetoresistive sensors there. And you can see the reluctor wheels here will be turned by the motor. And I can actually turn that on and cause those to spin. And so you can actually see that spinning behavior right there. As well, back in here, we can change the air gap for this sensor and this sensor. This sensor is less sensitive to air gap. This is really sensitive to air gap. So we can go from a minimum to some maximum. After some rearrangement, we're going to use our digital multimeter to look at our induction sensor. Notice that I have it on AC on the meter because we'll be doing AC, and I'm using a flute because we can measure the frequency with this, which is important. I've inserted the leads in here. I do not need my 5-volt power supply here because this is a passive sensor, so it's only a 2-wire sensor. I'm going to turn this on, and I'm going to rotate this to this position of this line, and I have called this the mid position line. This is a non-linear dial. You can see that from here. So if you turn it halfway, you're not really at mid position, but at least we have a line here where we're close to mid position. And if we look over here, we can indeed see that that's spinning. It's hard to get around the lights, but you can see it spinning. I'm going to come back here then and look at our voltage. And right now we're measuring a voltage. It jumps around a little bit. The reason it's jumping around because we have that large notch, and every time it hits that large notch, it messes up the average. But basically you can see it's right about 1 volt is where it's hanging out on the average. Now if we want to look at the frequency here, we can go here and hit the hertz, and we're measuring a frequency of 121 hertz. And so the hertz is a lot more steady than that. So we'll work with that to start with. If I increase my speed then on this position, you'll see the hertz will go up consistently. And in fact, at full RPMs, we can more than double that hertz on that sensor. If I go back down to mid position and get back to my volts AC, and this is where you have to really watch what's going on here and make sure you have the right thing. It says volts AC on there. I can show you the same thing from mid position to full position on voltage, and you can see that voltage as well is increasing. So we can see that this one actually works with the DMM and get some sense for it. The last thing I'd like to show you here before we go to the digital signal one is I can change the air cap. So I'm going to go here to maximum speed, and we're going to look at the voltage. And as I move the air gap, the voltage is dropping. And so the air gap matters that way. And I'm going to get out of a pretty small air gap. And you can see it's just getting smaller and smaller on voltage. Now I'm going to go to my hertz. Again, you got to watch the hertz is right there. I'm going to go back, and you can watch that hertz. I'm at full speed, and that hertz does not change as I change that air gap back. And so it doesn't have as much criticality for the air gap because we have a constant frequency for any speed, and the frequency changes as we move that speed. So now I'm back on this with the digital signal, and looking at the actual signal here, you can see the signal as it moves up and down on the teeth, and then the big gap is a large one that's larger than that. If we look at that, I'm on 1 volt per division, and so roughly that signal is running about 4 volts. As well over here, I'm at what I call the mid-position signal, and I'm at the minimum air gap. And so let's watch that as I change this and see what happens. And you can see the voltage is growing, and you can see the frequency is changing because you're seeing more pulses on the meter. And you can actually see now that I'm seeing that large notch twice in this display a lot of times. And I can keep going to full position, and that's what I see. It's actually bigger than my 1 volt per division. I'm off scale. Let's go back to mid. Let's stay at full then and see what happens as I adjust that air gap. And you can see that the frequency again does not change. It is simply the voltage level that is being reduced. And so that's the nice thing about the passive sensor. And the advantage with the passive sensor, this induction sensor, is that air gap is not all that critical, and I only have 2 wires. Okay, I moved down to sensor 2. Sensor 2 is the Hall effect sensor, and we'll note something different now. I do need my 5 volt supply because I have a constant 5 volts here, and you can see the signal, digital signal here. If I go to that 5 volts, I have 5 volts offset from my 0 point. And as soon as I go back on the signal, then what I see is I see what they call a digital signal. It's either at 0 or at 5 volts. And so the question then should be, what's going to happen is change the speed, for example, from mid position to full speed. And we'll watch that. I hope the answer doesn't surprise you. The voltage doesn't change at all in this one, but the frequency changes. And so that's pretty important to see. So I've then moved from the second sensor to the third sensor, which is a magnetoresistive sensor. And I picked this one because it actually has an air gap. The radial impulse wheel actually doesn't on the Hall effect sensor, and that's sensitive to distance. And so when we look at the signal now, this is left on my 1 volt setting, and so this signal is extremely small because it doesn't have the 5 volts supplied to it actively. It does have 5 volts signal, but it just looks at whatever that generates from that. So I really should probably change this a little bit to a different scale. And I can, as we go from mid speed, so we can go until we can barely move it. And we can actually see that digital pulse train. It's a very small digital cross train. Again, it's a digital signal. And as we move that up, then we are going to get more pulses. And so the frequency is changing. And we're not changing the air gap, so the signal stays the same. And that frequency continues to tighten up there, but we haven't changed it because it's a digital signal. It never changes. It just has the 2 levels, either high or low. If we move here then to the mid position where we can see those pulses pretty good and mess with our air gap, we'll see that, oh no, it doesn't take much movement. In fact, I haven't even got a full one, and I'm starting to get quite a bit of change in my frequency.